Hello. So today I'll be talking about how to solve the palindrome question, Leetcode question. Basically, choose what is a palindrome? It simply means a number, an integer that reads backward as the same thing forward. For example, 121 reads 121 forward and 121 backward. Unlike 123, it's read 121. So it reads 123 forward, but it only reads 321 backward. So it's not a palindrome. We have like two solutions actually for this. We have quick, easy solution, and we have the algorithm solution. The first one I submitted was, I think, this one is like a quick and easy solution in Python. If you look at it, um, basically you convert this into a string, right? And you convert this into a string and you check if the reverse of the string is true. Let's say they give you 123, you just convert it to 123 string, and you simply check if the last number and the first number are the same. If they are not, return false. If you go through everything, and you find out that, right, if you find out that, okay, they are not the same. For example, let's say I was given 123 number here. Oh shit, edit code. Let's say I was given like 123 number here. I was given right here, I was given 123 integer. I simply convert it into 123 string. Now what I do over here is I look over the 123 string, and I'm going to check if 1, which is the first character, is equals to the last one, which is what? 3. If it's not equal, simply tell me false. Simply return false. That means it's not a palindrome, right? So, and if I loop through, if I loop through and everything at the front and back are equal, that means that um it's a palindrome. For example, let's say this would be 121. So 121. So the first one is going to be 1, the second one is going to be 1, right? As you can see, and I'm only going to loop through half of the whole thing. So I'm only this particular string is of length 3. So I'm only going to loop through half of it. So basically 3, floor divided by 2, which is going to be 1. So I'm only going to loop through this first part. After I loop through, there's no need in checking this one because this one is a single digit. It's always going to, if these two sides are already equal, there's no point in checking the single middle because it doesn't change the fact that this is going to be a palindrome. Whether it's 2, whether it's 4, whether it's 5, whether it's 6, it doesn't change the fact that this is going to be a palindrome. So that is why I floor the number of checks. So let's say this were to be like 1, 1, 1, just making up something, 1, 1, 1, right? The fact that I'm going to check this side, I'm going to floor this number, which is 7, floor it, it's going to be like, 3. I'm going to get about 3, and yeah, I'm going to get about 3, and I'm only going to loop over the first 3, second 3, and if this were to be even, so it doesn't change anything. That's why I kind of floor to 3, to floor the number, and you check the first part, the second part, and if they're equal, boom, you are going to return true. Basically, I'm looking for the case whereby this index and the index at the front and the index at the back is not equal. If I find one, that means it's not a palindrome. If I don't find one, that means it is a palindrome. So this is like the easy way, very, very easy. Now, one of my other submission is this one, um, right? Right. So basically, I'm not going to convert this into a string. Um, yeah, I'm not going to convert this into a string. I'm simply going to carry 121, right? I'm only going to hold a temporary variable, right? 0, and I'm going to try to reconstruct. Try to reconstruct 121 from the back. So basically, I'm going to reconstruct that 1. How do I get the 1 at the back? Simply use modulus. Remainder rather. So use remainder, x remainder, this remainder of 10 is going to be 1, right? Save that, and the next time simply, so this 1 to 1 is going to become 12. The next thing you're going to do is that you simply modify the existing 1 by 10 and add the next remainder, which is going to be 2, right? Making your number 12. Then you go ahead and divide x. You go ahead and divide, you continue like that. Now, so that you're going to reconstruct this 1 to 1 from the back. That's what I'm doing. Now, I had a couple of optimization because there is no point in me trying to reconstruct everything. So let's say this were to be like 1, 2, 1, 1, 4, 5. Let me just make this easy. 1, 1, 1, 1, 1, 1. Right? Yeah. How does the palindrome? Yeah. Now, there's no point in me reconstructing the whole thing, right? All I need is to reconstruct half. Yep. All I need to do is reconstruct half, right? So basically what I'm doing is that I'm going to use remainder to pop. So I'm going to use remainder. No, let me make this into something very simple. I'm going to use, so we're going to have the temp. X is going to start as this, and the temp is going to start at this. So basically, X, I pop the last number, right? 1. This one is going to lose a digit, right? I pop the new one, 1 is going to lose another digit. I pop the last one, 1, right? So this one is also then going to lose another digit, right? And I'm going to pop another one, the 2 rather. So this one becomes 2, rather. So this one becomes 2, and this one becomes 1, 1, 1. Now what I do is that I check if temp, I put a condition that says, as long as, only do this while loop as long as temp is less than x. But in this case, temp becomes greater than x, so the loop stops. Then I'm going to return the case whereby I'm going to return true if temp is equals to x, or temp float 10. That means in this case, it's going to be 1, 1, 1 is equals to x. Is equals to x in this case, right? So you can see what I'm doing here. I'm simply using this trick so that I don't have to loop over the entire array, basically. Now, you might wonder what this condition is here, because this is a very funny one. Can throw off your algorithm, right? Right. So if you look at 10, if we apply our algorithm to 10, right, you pop the first number. If you pop 0, what are you going to get? You get 0, right? So it's kind of mess up the algorithm. That's why I put a conditional here that says anything that is divisible by 10, right? Cleaning the 0 by like anything whereby the remainder when divided by 10 is 0, provided it's not 0, should return false because it cannot be a palindrome. Yep, anything that is absolutely divisible by 10 cannot be a palindrome, so just return false. No need to waste our time. As you can see, so that's the algorithm for this case. It passes the check if you run it. So that's the basic rundown of if you're trying to solve this particular problem. All right, yeah, that's it.